Hello everyone, welcome back to Methods, Term 1, Week 6. We're into this stuff, anti-differentiation. Where we are at the moment is the fact that we've finished the differentiation stuff. Now we move into the opposite of differentiation. So anti-differentiation is kind of simple because it's just differentiation the other way. So if you started with a function, y or f of x, and you went this way, you'd be differentiating the function. Now a simple one would be power out front, lower the power by 1, done. Okay? E to the x would be differentiate the power, put it out front. Chain rule, product rule, quotient rule. Ways of differentiating. Now when we anti-differentiate, we're going back to this original function. But oftentimes we won't know what that original function is. So there's a couple of tricks along the way. So anti-differentiation and integration, that's just another word for anti-differentiation. Oftentimes people use the words, oh, just integrate that function. It's easier than saying, oh, just anti-differentiate that function. So integrate is a more common word, but it means anti-differentiation. Same thing. So if we had this example here, 4x squared plus 3x, if we were to differentiate it, we'd come here. You're going to be good with that. That's no problem at all. We've done that. Now up here, if we anti-differentiate or integrate y dash with respect to x. Okay? That's what this is saying. This is the anti-differentiation symbol, or the integration symbol, of a function, which in this case is going to be y dash, with respect to x, then that's just going to get us back to y, the original one we were at. So there's a lot in that for us at the moment, but it's saying integrate a particular function, which was already a derivative, with respect to x will get us back to the original function. Now let's do that with this function, 8x plus 3. Well, the rule is now raise the power by 1 and divide by the new power. Okay? Previously over here it was move the power out front and lower by 1. Well, to counteract that, we've got to raise the power by 1 and divide by the new power. And you'll see that if you work this part here, we end up with 4x squared, which is what we started with. It works the same here, raise the power by 1. Now this was just a number, so it's really 3x to the 0, isn't it? Raise the power by 1, divide by the new power. There's the 3x that we started with there. So you can see that it works. Simple example for now, you can see that it works. Okay? Let's do it with something a little more complex. We've got e to the 2x. Now remember, with differentiating e, we've got to differentiate the power, put it out front, but don't change this. This stays the same. So therefore this becomes 2e to the 2x. Okay? Now, this part here, let's talk about that. Think back to your graphing functions idea. A number by itself on the end, no x involved with it, no variable, is just taking the graph and moving it up or down on the axis. It's not actually changing the shape of the graph. And think, when we're working out the derivative, we're looking for how is the shape or the slope changing. Whether it's at plus 5 or minus 3 or plus 7 million, I don't really care. That doesn't change the shape or the slope. So hence when I take the derivative, that disappears away. Right? Doesn't seem so bad and you'd be okay with that. But now if we integrate that function, integrate it, same as what I had here, notice that I get back this part, but I don't get this bit. I don't get this, because I got rid of that. And remember, in a real question, you wouldn't know where you started. So you can't say, oh, but I knew it was there all the time. Well, you wouldn't know it. So what do? Well, we've got this issue of this constant dropping out. So what we do, we call this an indefinite integral, and we would write this. We would write y equals e to the 2x plus c. C is any number you like, and later on we might be able to figure out what C is. If we have a point on the original graph, we can then solve for C. But if we don't know where it is, because we don't know whether this was +1, +7, +10 million, then we just write this, recognizing that that gives us the family of equations. That is what we want. All right? Again, if we can find out later that we have a point on the graph, we can substitute in for y and x from that point and solve for c. Much like you do with a linear equation. I've got the gradient, I know it goes through that point, put it all in, solve for c. Same process, just a little trickier in the numbers sometimes. Well, that's a pretty quick little stroll on through anti-differentiation or integration. It's not difficult, but you need practice. Do lots of practice so you're 100% with all the styles that come up, because then we've got to build in more afterwards. Hope this has worked for you. Enjoy. Catch you later.